In this video, we'll learn about rational numbers in Math 9. In earlier grades, your child learned about whole numbers, decimals, integers, and fractions. A rational number is a number that can be expressed as a fraction, so all of these are also rational numbers. What's new in Math 9 is the inclusion of signed decimals and fractions. Before we investigate operations with signed decimals, let's review operations with whole numbers and integers. We'll begin by taking a closer look at the meaning of division. What does it mean to divide 12 by 3? One way to represent division is to use a number line. What does 12 divided by 3 look like on a number line? Can you visualize this in more than one way? You might have thought about 12 divided by 3 as partitioning 12 into 3 leaps on a number line. Each leap travels a distance of 4. So 12 divided by 3 is 4. We can think of 12 divided by 3 in a different way. We can measure distances of 3 and count how many leaps there are. 3 goes into 12 4 times. We know that the number line doesn't start at 0. It extends forever in both directions, giving us the integers. We can ask questions about operations on integers. For example, what does negative 12 divided by positive 3 look like? Again, we can visualize this as 3 leaps on the number line. And again, each leap travels a distance of 4. Because these distances move us further to the left and away from 0, we label this measurement negative 4. What does it mean to divide by a negative number? What does negative 12 divided by negative 3 look like? We might think of this as how many negative 3's are there in negative 12? There are 4 leaps, so negative 12 divided by negative 3 is positive 4. We can zoom in on the number line. This lets us explore negative decimals, part of rational numbers in Math 9. What does negative 1.2 divided by positive 3 look like? Three leaps of 0.4 to the left land us at negative 1.2. What does it mean to divide by a negative decimal? What about negative 1.2 divided by negative 0.3? This asks us to figure out how many negative 0.3's there are in negative 1.2. This investigation shows that we can think of division on rational numbers in decimal form in the same ways that we think about division on other numbers we know. The rules for multiplying integers, summarized here, extend to rational numbers. The rules for adding and subtracting integers cannot be neatly summarized. The sign of the result depends on the magnitude of the numbers that we're working with. Again, this extends to rational numbers and is the focus of our next exploration. One December day in Surrey, BC, the temperature reads 5.3 degrees Celsius at 7 p.m. The temperature is expected to drop 6.5 degrees Celsius overnight. What will be the temperature at 7 a.m. the next day? How do you know? Let's zoom in on the thermometer, a vertical number line. The temperature in the evening is 5.3 degrees Celsius. Overnight, it drops 6.5 degrees Celsius. We can express this change in temperature in two ways, as a decrease of a positive temperature or an increase of a negative one. Either way, it's colder. A quick note about mental math. It might be helpful to split 6.5 into 5.3 and 1.2. Whether we subtract positive 5.3 or add negative 5.3, we hit 0, before falling another 1.2 degrees below 0. On that same December morning, the temperature in Kamloops, BC reads negative 11.8 degrees Celsius at 7 a.m. What is the difference between the temperatures in Kamloops and Surrey? Again, let's zoom in. To determine the difference between the two temperatures, we subtract. Subtracting the temperature in Surrey from the temperature in Kamloops gives negative 9.6, whereas subtracting the temperature in Kamloops from the temperature in Surrey gives positive 9.6. So which is it? Both work. However, we usually speak of differences in temperature using positive numbers. Let's turn to operations on rational numbers in fraction form. The procedures for adding, subtracting, multiplying, and dividing fractions apply equally to signed fractions. Our Math 8 Operations with Fractions video discusses these in more detail than we will here. A quick discussion though. In earlier grades, your child learned to add integers and fractions. Math 9 brings these two together. Notice that we are adding two fractions. Also, notice that one fraction is positive, the other negative. To add fractions, we express them as equivalent fractions with a common denominator. Next, we add the numerators over a common denominator. Finally, we apply our understanding of adding integers to add the numerators. The sum is positive 1/6. Let's apply our understanding of rational numbers to some problems from the textbook. A submarine is cruising at a depth of 153 meters. It then rises at 4.5 meters per minute for 15 minutes. What is the submarine's depth at the end of this rise? The cruising depth of the submarine can be represented as negative 153 meters, 153 meters below the water's surface. The speed at which it's rising is positive 4.5 meters per minute. Multiplying this by 15 gives the rise of the submarine. Let d represent the depth at the end of this rise. Adding the rise to the original depth gives us the new depth. The depth of the submarine is 85.5 meters. It's understood from the context that this is below sea level. What do you notice about this pattern? The numbers are increasing. The negative fractions get closer to 0 and then a positive fraction appears. But how is this pattern increasing? To figure this out, it will be helpful to express the fractions as fractions with a common denominator. The numerators are increasing by 5. The fractions are increasing by 5/8. This difference is common to any two consecutive fractions, like negative 2/8 and positive 3/8. Continuing to add 5/8 to each successive fraction gives us 1, 1 5/8, and 2 1/4. Let's look at a different pattern. What do you notice about this pattern? Again, it might be helpful to express the mixed number as a fraction. This time, the numbers are alternating between positive and negative fractions. This means that the pattern rule must involve multiplying or dividing by a negative number. Also, the fractions are getting smaller and smaller. We can see that each fraction is negative 1/2 of the fraction that comes before it. This ratio is common to any two successive fractions, like negative 1/6 and positive 1/12. Continuing to multiply by this ratio gives us what comes next. Let's look at one common mistake that students might make. The correct calculation of negative 2/3 times positive 3/4 is shown. Notice that a negative fraction times a positive fraction is a negative fraction. A student might apply the negative sign of a negative fraction, like negative 2/3, to both its numerator and denominator. Following this through gives positive 6/12. However, we now have a negative times a positive equal to a positive. And this is incorrect. Other common mistakes may be addressed in our Math 8 Operations on Fractions video. This video addresses several learning standards in the Mathematics 9 curriculum. In content, we looked at operations with rational numbers. Several curricular competencies may emerge as your child learns this content in their classroom. In this video, we visualized a number line to make sense of dividing rational numbers. Further, we connected operations on rational numbers to our understanding of how we operate on other numbers we know.